Hello again. Thanks for joining us and welcome. This is, believe it or not, episode 500 of Space Nuts. Can you believe it? And what have we got in store for you today? Absolutely nothing. We didn't have time to organise anything. But we will be answering audience questions. It's a Q&A episode. We have got a few remarks that have come in. I'm always scared of remarks, but anyway, we'll deal with that. We've got a question about Big Bang Theory. We've got another question about the collision with Andromeda, cold welding. I've never tried it, but I'm willing to give it a go. And a question from Mike, who's asking all of us about our favourite upcoming missions. That'll be fun. It's all coming up on this episode 500 of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining us for this auspicious occasion, or it's just another episode, whichever way you want to look at it, is Jonti Horner, Professor of Astrophysics at the University of Southern Queensland. Hello, Jonti.
Good evening. How are you going?
Good, thank you. And Professor Fred Watson, Astronomer at Large, back in the chair. Hello.
Hello, Andrew. And nice to be back is the answer.
Yeah, and jet-lagged hell, obviously. It's all right. It'll come back to you. You've had plenty of time to forget how we do this, but it'll come back good and proper.
Who am I again? I can't remember.
Yeah. Yes. It reminds now, who was it? Graham Garden, who was with the Goodies. Remember him?
Yes, I do.
He was on another TV show once, and they were I can't remember what the circumstances are, but they were all doing pickup lines at nursing homes. And Graham Garden went, "Hello, who am I?"
It was the radio show. It was I'm sorry I haven't a clue.
That's what it was.
Which is fabulous.
Oh, brilliant stuff. Brilliant stuff. You could probably dig that stuff up on YouTube or somewhere these days.
Oh, no.
Very funny radio. Mm. Now, I want to start off with not so much a question, but a comment.
I've been at an academic conference. This is more of a comment than a question.
Yes. Hi, guys. I'm Michael from Glasgow, Scotland. Thanks for your great show. That was the comment. No, thanks for your great show, which I've been listening to for several years now. Here's my thoughts on a subject much discussed. We know that words are powerful, that powerful equals energy, and that energy equals matter. My theory is that dark matter is the mass equivalent of all the bad one-liners, dad jokes, and awful puns that Andrew has collected and shared over the years. Dark energy is simply the rest of the universe trying to get away before he delivers the punchlines. Should I collect the Nobel Prize or a coat on my way out? Wishing you and your nearest and dearest the best for, the festive season. See how long it's taken me to get to this one? And for 2025, Michael. Thanks, Michael. Great comment. I appreciate it. And just watch my boot on your way out. I think that's
Actually a good one. It allows me to segue into a fabulous British author who is dearly missed in the form of Terry Pratchett. Sir Terry Pratchett, who, when he was knighted, forged his own sword out of star metal, which is kind of awesome. And Pratchett was an incredible author and incredible visionary, but he came up with this very similar concept. There's a bit in Guards, which is, I think, the 8th of the Discworld books, where the librarian of the Unseen University, who is an orangutan for various reasons, is trying to go back to figure out who stole a book. And there's this beautiful paragraph about how collections of books and collections of knowledge distort space and time. And Pratchett says, the relevant equation is knowledge equals power equals energy equals matter equals mass. A good bookshop is just a genteel black hole that knows how to read. Matter distorts space into polyfractal L-space, in which everywhere is also everywhere else. And basically goes on to allow the librarian to travel back through the hidden shelves of L-space to work out who had committed the heinous act of stealing a book, which is clearly a crime far more important than murder or anything else that the Watch is dealing with at the time. Fabulous books, but he often had science-inflected humour in there. And yeah, it's lovely to be able to reminisce and think back to him. Thanks to what's a fabulous comment.
I think he also invented my wife's alter ego, Granny Og.
Yes.
Because Granny Og is the person to whom I'm married, and she's a step granny.
Oh,
I've actually got sat on my desk here the first real Discworld-based book that has been come out other than for Terry Pratchett, which is put together by his daughter Rihanna, which is Tiffany Aiken's Guide to Being a Witch. And yeah, Granny Weatherwax and Nanny Og feature prominently in the beautiful cover art there. So, yes.
There you
okay.
I'm not getting commission for that.
You might. To our first question, is there any conclusive evidence that the Big Bang did not occur in an already existing universe? I love your show and never miss an episode. Keep up the good work. Joe from Washington. So is there any conclusive evidence that the Big Bang did not occur in an already existing universe? Now,
It's a challenging one.
I've got you on record as saying, when I've asked the question, what was there before the Big Bang, and you said nothing. Well, you answered it, but your answer was nothing.
Well, just I'm going to throw this one direct to Jonti and see what he says in answer to it. My answer is we don't know. Our best theory for the way the universe works is general relativity, and general relativity says that time started with the Big Bang, and so there wasn't a universe there before. But that theory is challenged by people who think there might be a multiverse, and by quantum mechanics who think that you've got to have time before the Big Bang for quantum mechanics to work. And so it's all a bit messy, but there's no evidence. In fact, really, there's no evidence either way. What will that be, Jonti?
Well, we're a bit back to more Pratchett, aren't we? In the beginning, there was nothing which exploded.
That's right, yeah.
The hard part for this, and again, I'm not a cosmologist, I think our wonderful colleagues down the hill at the University of Queensland would be well placed to also fail to answer this question, but they'd tell straight from a position of much more knowledge than I have.
Oh, me.
But my take on this is that space and time are inherently of the universe. So when people ask me a question that's related to this, which is what's outside the universe or what's before the universe, in the framework that our cosmological friends have come up with, those questions are meaningless because you can't be outside the universe. Because to be outside, you need to be in somewhere that is spatial, so you're actually still in the universe. The idea is that if everything in the universe, when you rewind time back, ends up in exactly the same place, but that place is everywhere all at once, then having that been something that is already an existing universe outside that falls into that same philosophical problem. And it's where I think cosmology and philosophy blur together, because if the Big Bang creates space and time, then the concept of outside the Big Bang is the same as before the Big Bang, and it becomes meaningless. It's like a divide by zero error. What that probably means is I don't understand the theories as well as I should do, but it also probably means that our theories are not yet at the final evolution of them, because there are questions we still can't answer. And this is something we see with kind of the iterative nature of science, is that you get a theory that explains everything you can observe and everything you can ask, that does a really good job for a really long time until you get better at studying the universe and you start to find the cracks. And I think this is one of the questions that's illustrating cracks that we haven't explained yet. So we can give you our best imagination of what it could be, but the reality is, as Fred says, we just don't know. And that's why people are doing the research. You know, if we knew the answer already, it wouldn't be research and it wouldn't be worth doing.
Yeah, we've had questions about this many, many times over the years, and even people with their own theories. Could the Big Bang be the result of a previous universe collapsing in on itself? So the Gnab-Gib creates a Big Bang. That one's been tossed at us, and a few other thoughts. Look, yeah, the I don't know answer sits pretty well with me at the moment, because how could we possibly figure it out? That's another question.
Well, that hurts my head as well, because I occasionally come back to this. We know an incredible amount about the universe, and we've worked a whole heap out with a couple of kilos of mushy goo, mushy carbon. It's amazing what you can work out. But there's still more to learn, and that's a good thing, because otherwise we wouldn't be employed.
Yeah. That's a very good point. Come to think of it, I'm not employed by anyone for anything. Yes.
So the cracks are interesting. I mean, and perhaps it's just worth highlighting what led to the idea of multiverses in the first place, which are, one is the fact that it's the what's it called? I can't remember the word. I'm jet lagged. Anyway, the fact that we seem to have a universe that's fine-tuned for life to exist.
The anthropic principle.
That's what I thought it was anthropic, but my brain said no, it's something else. Anyway, that's all right. And you know that's what led people like Martin Rees, who I think coined the term multiverse, to and the Astronomer Royal, to postulate that maybe there are other universes out there that are not fine-tuned for life to exist, and the one we live in happened to be the only one that has. That is. And the other thing that intrigues people is, you know, the four fundamental forces of nature, the weak and strong nuclear forces, the electromagnetic force and gravity. Gravity is hundreds of billions of times weaker than the others, any of the others. And so some have suggested that maybe gravity leaks out into whatever the void is between our universe and next door's universe, which I think cosmologists call the bulk. I've got a feeling Doctor Who called it the void. Is that right? I can't remember. Anyway, it's the space between universes, which must exist in a higher dimension. And we don't know about high dimensions yet. But if we did find out about higher dimensions, then we might start thinking of answers to this exact question.
You never know. One day, maybe somebody will make a breakthrough and we'll know exactly what happened, but I'm not holding my breath. Okay, thanks, Joe. Great question as always. It's one of the more regular questions we get on Space Nuts about the Big Bang. It's right up there with dark energy and black holes and dark matter. Question 2: with the collision of Andromeda and the Milky Way some 4.5 billion years from now, it's in my diary. How close to each other will it take the two galaxies to start affecting one another? And to add to that, will solar systems likely collide, or is there so much space between everything that that part won't happen? Thanks, guys. Dan from the Gold Coast in Australia, up in Queensland, not far from you, Jonti. This is a good one. I think we've talked about the slow motion effect that's going to be the collision. But are they going to affect each other before it happens, or are they maybe affecting each other already?
Exactly.
Absolutely.
Yeah.
And it's a matter of how big an effect you want the effect to be before you recognize it. If you think the diameter of the Milky Way is usually scoped as being about 100,000 light years, so that means something that is on the edge of our galaxy that is nearest to Andromeda is about 50,000 light years from the middle of the Milky Way, and about 2.5 million light years from Andromeda, roughly. So Andromeda is a lot further away, but Andromeda is a bit more massive. What that means is that Andromeda is exerting a force on those stars in the Milky Way, but it's exerting a differential force across the Milky Way. So the stars at one side of the Milky Way feel Andromeda pulling more strongly on us than the other. So that means that there will, in a very realistic sense, be a tidal effect on our galaxy caused by Andromeda at the distance away that it is now. Now, whether we've actually detected that yet or not is another matter, because we've got a lot of weird stuff going on with our galaxy. It's got other galaxies interfering with it as well, like the many satellite galaxies we've got. So I think the answer is that they will already be interfering with each other. They'll already be affecting each other. But it's likely that the scale of that at the minute is too small for us to readily detect. But it doesn't mean that it isn't happening. I guess much the same way as instantaneously the gravitational pull of the moon is affecting you, but you don't ever notice it because it's such a small effect. As they get closer together, that becomes a bigger and bigger effect. And they will start to noticeably distort each other before they're physically in contact. So if you were on the outside looking at the disks, there are stars from our galaxies further out than the disk. There are just not many of them, so you don't see them. But they will start distorting and affecting each other long before they are physically coming into contact. But then when they do, everything in them is so spread out and space is so big that it isn't like planets will collide with planets and stars with stars. I think I saw someone worked out statistics at some point that said if one star from Andromeda collides with one star in the Milky Way, that would be unusual. And our galaxy's got 400,000 million stars. Andromeda's got about 1,000 million stars. But space is just so big that they'll pass through each other without physical collisions. The gas and dust will collide, we'll get a starburst event, so loads of new stars will form. It will be interesting times, but the Earth is unlikely to be hit by an Andromedan Earth.
Ah, all right. Yeah, well, it was an interesting thought, but if the stars are going to miss each other, then the solar systems are not going to collide either, are they?
Yeah.
And that'll just, and I think you did describe it as a sort of a slow motion ballet type of an event, Fred.
That's right, because the two objects kind of spiral around one another before they merge to become Milkomeda.
Milkomeda.
Yeah.
And then everything gets very boring a bit after that.
Yes,
It's a starburst event, gets rid of all the gas and dust, and the galaxy just gradually ends up as a pretty amorphous blob of doom.
Yeah.
A dead galaxy.
The sky will be very different, though, won't it?
Will eventually. It'll start off being a lot more dramatic. Andromeda will get quite big in the sky, then the Milky Way will get noticeably distorted but noticeably brighter with all the star formation. But then when it all dies down, you'll just end up with, instead of the Milky Way, a kind of amorphous, blobby, half of the sky is a big blob, because our galaxy will end up as a big spherical galaxy with very little star formation, like Messier 87's the archetypal elliptical galaxy. And that is essentially galactic senescence. So that's when the Milky Way goes off into a nursing home complaining about how things aren't as good as they used to be.
Well, yeah, and it also goes with the theory that beauty fades with age. So, that's probably where it's coming.
Speak for yourself, Andrew.
Fred's always an exception to the rule. Okay, thank you, Dan. I hope we adequately answered your question. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson and Professor Jonti Horner.
Roger, your last clear here also.
Space Nuts.
Next question on episode 500 comes from Sean. He's in Oliver, British Columbia, Canada. I just became aware of the concept of cold welding, where the same kinds of metal fuse together in the vacuum of space. I'm hoping you can talk a bit about that. It seems to me that it is a critical process in planet formation, and I'm wondering if the role this. I'm wondering about the role this may play after a star explodes and all these newly formed elements clump together. Love the show. Miss Fred and Jonti is a great addition to the team. Well, you're lucky, Sean, because they're both here. So cold welding. Have you heard that term before, either of you?
I have.
Yeah.
It's an interesting one. I've seen little video clips to do with this, and it is to do with blocks of metal. So my understanding, and Fred can correct me when I'm wrong, and I think it is a when rather than an if in this case, but my understanding is it's with lumps of metal in particular. So lumps of water ice won't cold weld to the same degree. You'll get some degree of stickiness between them. But with lumps of metal, this thing can have such a strong effect that you don't even see a join. There is that degree of agglomeration of sticking together, and it's to do with how metals behave and how free the electrons are to move, which is part of what allows a metal to be incredibly conductive. It means that metals can essentially stick together incredibly strongly because of the electrons moving freely between them. That's kind of my loose understanding of it. Now, why that isn't too critical for planet formation is metals are only a small part of that. So if you got two lumps of metal come together very, very gently, they would kind of cold weld together, but they would kind of be tending to bounce off each other unless they have something causing them to stick. So if they hook together a bit, this could help them agglomerate into a single piece. But I don't think it would help the much bigger scale solid material stuff that's going on to do with dust grains and ices. So I don't think cold welding works if you're in a situation where you don't have that mobility of the electrons, where you don't have that conductivity, essentially. So that's why I don't think it seems to be a critical process in planet formation, but I suspect it will have happened at times in planet formation and since. For example, if you got, and this is quite an extended series of events that will cause this, but you get asteroids that become large enough to differentiate. So they get a hole in their interior, the metal sinks, the rocky stuff floats, like we've got on the Earth. So you get a core and a mantle and a crust. Then you smash them apart. That's how you get the different types of meteorites we get that have been processed. So you get the evolved material, you get the stony meteorites, the stony ions, which come from the mantle core interface, and then you get the metal meteorites. And the biggest object like that is possibly Psyche that we know about, which is the mission going to at the minute. If you did that and then you shattered that enormous metal asteroid Psyche, but you shattered it fairly gently so the bits still came and butted against each other, they could then cold weld back together, which gives you almost this image of the kind of Terminator-style asteroid that you cannot destroy. And that's the kind of scenario where I could see this happening. But in general, I think it would be a very niche area that wouldn't happen often in planet formation, so wouldn't be that critical. I don't know, Fred, if you want to add to that or if you have additional thoughts to do with it.
No, yeah, you've absolutely nailed it, Jonti. The only thing I was going to add is that certainly in the process of planet building, it's going to be hot welding. It's basically just chunks of metal fusing together. If you fusing together because they're mixed up with the dusty and silicate stuff and the ices. And so those collisions actually heat the material. If there are metallic components, they will fuse, but it'll be mixed up with all that other stuff until, exactly as Jonti says, it differentiates and all the metal sinks to the middle and gives you a solid core if it cools down. And maybe, I think your analysis of what happens after that is right as well, that if you get something smashing into a protoplanet, or more likely planetesimal, a smaller stage, then you might get lumps of metal, literally uncontaminated metal, if I can put it that way, that could cold fuse. I think it's not an important process in the whole scenario of planet formation, though.
Yeah, so, where it is important, though, I think, is spaceflight, and it's important as something you want to avoid. Now, if this is why you would paint your metal surfaces. I mean, if you think about the arm that used to come out of the space shuttle to grab onto things, when that folds up, you don't want it welding itself solid so it can't move anymore. And I guess that's part of the reason you paint all those things. So it's something people have to be very aware of with spacecraft design in the vacuum of space.
So his second part of the question about exploding stars, supernova, whatever you want to call it, creating all those elements could clump together, but as you say, not a critical process in planet formation.
Yeah, I think this will be a very small and minor thing. I wouldn't rule it out happening occasionally, particularly when you get to the size scales that you're no longer thinking of individual molecules, but you're thinking lumps of stuff. But when you're not big enough for the lumps of stuff to become molten when they hit each other, and when those lumps of stuff hit each other very gently, so they just nestle up together. And, if you can have two bits of metal that nestle up against one another, then this will happen. But that's going to be a very minor part of the process if it's significant at all.
Okay, very good. Thanks, Sean. Great to hear from you. Hope all is well in British Columbia.
3, 2, 1.
Space nuts.
We've got time for one more question. It's an audio question, and it's sort of an open-ended question, which will become self-explanatory. It comes from Mike.
Fred and Andrew, hi. It's Mike Cupid here from the northwest of England in the UK, and I have a little bit of a wishy-washy question for you, if I may. Now, you guys have always affirmed that space exploration is slow. You can't start a mission and expect it to yield results after a week or two. Everything you do seems to take years. However, there seems to be an awful lot going on at the moment. Just off the top of my head, without even scratching the surface, we're trying to work out what's going on with dark matter and dark energy and what it actually is and what's causing it. We're talking about setting up a permanent moon base. We're talking about man setting foot on Mars. We're talking about the search for sort of extraterrestrial life within our solar system and further afield. It's just absolutely mind-blowing. Now, my question for both of you, if that's okay, if you had to pick one field of research or one mission that gets you more excited than anything else, your favorite thing that's going on at the moment, what would it be? And what do you hope it yields in the next sort of 10 or 15 years? What do you think the results are going to be? A lot of what you guys say absolutely astonishes me, just absolutely blows my mind. And I'm sure I'm not the only one, but I just really want to know what blows your mind, what gets you excited. Thank you very much for the show. I don't think I've ever missed a single episode. I think you've been absolutely brilliant. I hope it never stops. Thank you very much for your work, and keep it up.
Thank you, Mike. Love that question, and I love these open-ended ones where they throw it back at us. And Mike, it's your lucky day because we've got two people here that can shed a bit of light on what they think is their favourite upcoming mission. Can I go first, just so we can get the lame stuff out of the way? I actually wrote down three things that excite me. Obviously, Artemis 2. That to me sort of takes me back to my childhood watching the Apollo missions, and so I'm really excited about that. This is not so much a mission as something that I'm really looking forward to, that you and I have, well, all of us have spoken about in previous episodes, and that's the commissioning of the Vera Rubin telescope. But my favourite, which we've already talked about in the last episode or two, this is the one I'm really excited about, is the Europa Clipper mission. I think we've already mentioned it today. I'm excited about that because of the potential, the possibility they may be able to confirm the existence of life on an ice moon in our solar system. I hope they can. That's my big hope, Mike, that this mission will, without doubt, be able to nail down the fact that we are not alone in the universe. We might be sharing it with a couple of germs on an icy planet or an icy body, or maybe krill. I don't know. But the fact that we have been discovering more and more bodies in our solar system that have oceans is extraordinary. And we spoke about one in the last episode, Callisto. And now we're going out there to see what we can find. That really gets me ramped up. I can't wait to see how this goes. I'm really, really hopeful that they will be able to go, yep, we found a frog. And
You'll be riveting.
Yes, it will make a lot of noise about that. So that's the one for me, Mike. That is the one for me, the Europa Clipper. And you said it. I can't remember the European Space Agency mission was.
And with the Jupiter Icy Moons Explorer, which is one I'm watching with interest because I was at one of the first little meetings when that was being planned back in 2004, just after I'd started my first ever postdoc. And I ended up needing to borrow €10 from a really senior scientist to get a taxi because the cash point wouldn't give me money or something like that. So it was an interesting experience for me.
Excellent. All right. So that's mine. Jonti, what do you reckon?
I've got a couple. I mean, it's worth mentioning Juice because of that personal connection to it, even though it's a very brief personal connection. The fact that 21 years after I was at that meeting, the thing is still on its way and hasn't got there yet tells you how long these things take and what a big part of people's lives they are. The two that I wanted to flag up, I talk a lot about Vera Rubin. We talk a lot about things like the Rosalind Franklin lander going to Mars, the Icy Moons Explorers, both of them going out to Jupiter. But the two that catch my eye are the Comet Interceptor mission. So, my first love has always been comets and meteors. And this is a mission that was proposed in the aftermath of the interstellar objects we saw came through. So Oumuamua and Borisov. Team of researchers put together a very basic thing saying, wouldn't it be awesome if we had a spacecraft sat in a holding orbit, ready to go when we find a comet that's interesting to actually go visit it? Now, in the past, we've been to comets and we've been to the ones that we could predict coming. So we knew in advance we could trundle off there and catch them because we had plenty of warning. And that means we've seen comets that are old, comets that are evolved, that have had a lot going on. And in reality, probably comets that have their origins in the Edgeworth Kuiper belt beyond Neptune. We've never really been able to visit an Oort cloud comet, a comet coming in for the first time, or an interstellar object. And so this mission was devised, which is hopefully going to launch in 2029, possibly on the same spaceship as Ariel, which is a planet characterization mission that Europe are putting together that is also going to be awesome. And then it's going to hang out there in space, parked there until the right object is discovered. Now, thanks to Vera Rubin, we'll get much more notice of the right object. We'll probably find interstellar objects by the dozen rather than just 2 that we've ever had. And this thing will be there ready to go. So even when it's launched, we won't know where it's going. And then we'll sit and we'll wait, and the right thing will be discovered, and then it will jet off to intercept it. And I think that's just a fabulous step forward in technology. The other one is the Dragonfly mission, which is scheduled to launch in a few years' time. We'll probably get to Saturn in the mid-2030s. And it's destined to go to Titan. Now, Titan's the only other object in the solar system than the Earth that experiences rain and weather in that sense. So it probably feels very much like the previous caller from the northwest of England, like their day-to-day life, to be honest. It's grey and overcast and there's a lot of stuff falling from the sky. Titan's a really bizarre place. So on Titan, you've got the water ice is harder than granite. So the rocks are made from water ice. But you've got rivers and oceans and rainfall made of liquid methane and liquid ethane. And it's a fascinating world. And the only time we've ever touched its surface was the Huygens lander, which landed with a little penetrometer spike on the bottom. Confused colleagues of mine who were at the Open University, who were the first to handle the data, because they'd run all these drop tests of different materials that the surface of Titan could resemble, and none of them worked. And then they thought to try creme brulee, and that's what it was, because it's got a firm, crisp top and then a soggy bottom, essentially. That's the only time we've ever spent there, and that was a very brief fleeting touch on the surface, whereas Dragonfly is going to be something comparable in size to a golf cart that is a quadcopter but with 8 rotors instead. So I think that makes it an octocopter, which sounds like something out of a bad sci-fi movie, a helicopter with pentacles. And it's going to fly around. It'll have this huge radioisotope generator. And during the day, it will fly around, take observations, visit new places, check out what's happening, search for things like the possible evidence of life in this totally alien place, send back weather reports saying I've gone to another world and it's raining here as well. Welcome to Manchester. And then at night it will land and it will recharge. And the nights on Titan take 7 Earth days to complete, recharge from the radioisotope generator, and then be ready to go the next day. So for however long this mission lasts, we're going to be getting live weather reports from another planet, and we're getting live images from a place we've never really visited before. Exploring, it's going to be absolutely breathtaking. And the technology challenge of this is bonkers, because this environment where you're going to build a quadcopter that will have so many moving parts it can fly is 180 degrees below freezing. So you talk about cold welding, those kind of things are a problem. A lot of the materials we use on Earth won't work. They'll be too brittle. So there's huge technological challenges for this, but it's in development. I think it's currently scheduled to launch in 2 or 3 years' time from now. We'll have a nice toasty 7-year cruise to get there, and then we'll fly back, and you'll be able to get a live weather report from Titan, another world on which it rains. So I'm very excited about that.
That's amazing. Yeah, that sounds really exciting. Fred, what's your favorite or upcoming mission that tickles your fancy?
Okay, 2 things.
Isn't it interesting we can't settle on one?
Well, no, we can't, no. Well, they're both close to my heart, actually, for different reasons. So one's got its feet firmly on the ground, costs much less than a space mission, 1/6 of the cost of the James Webb Space Telescope, but many, many times bigger. And that's the ELT, which is taking shape on Cerro Amazones in northern Chile. And the way they're progressing with it is just astonishing. It's looking like a finished telescope now. It hasn't got its 798 mirror segments yet, but it will have. So the ELT, the Extremely Large Telescope, the European Southern Observatory's flagship instrument, which we still expect to come on stream in 2028. And that will be a date to look out for, and we'll cover it in Space Notes. Jonti, you have something?
I was just going to flag up with that. The numbers with that are truly bonkers. So we're in Australia, where we've got the biggest telescope in Australia is the Anglo-Australian telescope, which has a primary mirror of 3.9 meters diameter. The ELT's mirror will be 39 meters in diameter. So the primary of this telescope is 10 times the diameter. So that's 100 times the collecting area. The secondary mirror of this telescope is bigger than the mirror on the Anglo-Australian telescope. The tertiary mirror is still 3.9 meters. So the third mirror on this thing is nearly as big as the biggest mirror on the biggest telescope in Australia, just to put into perspective how big it is. So, yeah.
That actually, the thing that blows my mind, because of course I was the astronomer in charge of that telescope, so I know its enclosure very well. But the mirror diameter of the ELT is 3 meters bigger than the diameter of the dome of the Anglo-Australian telescope, and it is a very generous dome.
Oh, it is.
It's one of the biggest domes in the world. Anyway,
Looking at photos at the moment of the progress of the construction,
ELT, yeah.
It looks stunning. It's an amazing, to quote you, Fred, it's an amazing piece of kit.
Yes.
Well, the fact that having walked around that catwalk on the edge of the observatory, Fred, I'm thinking that catwalk is smaller than the mirror is going to be in the place.
It's mind-blowing, isn't it? So, yes, so that's to come. 2028, we'll see first light. It might happen before that with a fewer number of segments of the mirror. But looking forward to that, because it will pretty well revolutionize all aspects of astronomy. It's going to, it's got the whole textbook of astronomy to basically rewrite, and I'm sure it will. Something a little bit more. Sorry, go ahead.
Timed with Vera Rubin, because Vera Rubin will find stuff, and then the ELT will understand it. And so really that partnership synergy there.
That's correct. And that highlights what I was about to say, that what you really need is a survey telescope to find the really exciting objects. And that was the symbiosis between United Kingdom Schmidt telescope, which is what brought me to Australia in the first place, and the Anglo-Australian telescope. They work perfectly well together, one with a wide-angle camera and the other with the capability of homing in on the details of the objects that were being discovered. And it's the wide-angle aspect that excites me with my final mission that I think is going to be very important. And what is brilliant is that launches in 3 days' time. It's a spacecraft called Sphere X. And Sphere X is an acronym, as you might guess. It's short for Spectrophotometer for the History of the Universe, Epoch of Reionization, and ICES Explorer. It's a bit convoluted, but that's what it is. It's a relatively small telescope. It will go into orbit, but what it will do, because it's basically a wide-angle telescope in the infrared, it's like a wide-angle James Webb telescope. It will take images of 1 billion galaxies, 100 million stars, and 10,000 asteroids. And that is in order to look at the three particular aspects that this spacecraft is being launched for. One is the cosmology questions, the big questions. How did the universe begin? In particular, was the epoch of inflation, that's that time a gazillionth of a second after the Big Bang, when it became 10 to the 50th times bigger than it was a gazillionth of a second ago, was that real? We have every reason to believe it was, because it's the only way we can make the theories work. But this spacecraft will measure the geometry of the universe in such a way that we will get insights into that process, the inflation process. It will also look in detail at the evolution of galaxies, the way they string out along the filaments of the cosmic web. But coming closer to home, it will be looking for ices, for carbon-containing organic molecules, all of that stuff, which is really designed to look again at the question that we all have on our lips at the moment, and I have done probably for the last 400 years. Are we alone? Are there other living organisms? Because we'll see the building blocks of life in detail and see where they are, not only in our own galaxy, but probably in galaxies beyond. So this Friday, Sphere X launches, and we might have some answers before 2026. How's that?
Yeah, very exciting, very exciting. And best of all, Sphere X gets off the ground a day before SpaceX. So that's, thank goodness for that. Yes. That brings us to the end of episode 500. Look, we had big plans for a very exciting special guest, but Hugh in the studio said no. So what can you do? But all jokes aside, though, I want to say special thanks to our sponsors who have been on board with this, some of them for years. I especially want to thank the audience for backing us up for so long. Fred, you know as well as I do, when we started, we didn't think we'd last a few weeks. We really didn't believe that it would take off, and we've been enjoying a very long ride at the crest of a couple of waves on the various platforms out there that are well known. Sometimes number one or number two on the iTunes science list. So we couldn't be more thrilled with that kind of success, and that's because of you, the people who download us week in, week out, despite Apple updates. And I give him a hard time, but Hugh Drury, who is the brains and the brawn behind not only this podcast, but several others in the stable that you'll find on bytes.com. Hugh's a tireless worker, and I'll often get emails from him from 1 o'clock in the morning because he's sitting in on a conference, or he's learning something, or he's putting the final touches on a show. He does a fabulous job, and I did say once before I'd never say anything nice about him again, but he deserves it. He works so hard, but it could not be done without the likes of Jonti Horner and Professor Fred Watson. Thank you both. I'm glad we could all be together for episode 500.
Me too.
I am in awe of what you do, and it's such a thrill for me to be able to team up with you guys every week and talk about this stuff that has just got people around the world thinking, wondering, and coming up with ideas that they throw at us about, could this be the answer to to dark matter or dark energy or black holes or whatever. And getting emails from people saying, we've published this paper because we listened to your podcast. That happened while you were away, Fred, but I sent you the email. Yeah. I mean, that just, that is probably one of the greatest thrills that I could experience, that we have inspired people like that. So I'm so happy to be a part of it. And, 500 down, many, many more to come, I hope. Thank you so much, gentlemen. Appreciate it. Very much.
And thanks to you, Andrew, the man with the silken voice that keeps this whole thing running and has the world's, probably the universe's worst dad jokes thrown in for nothing. So,
yes, without them, there'd be nothing.
Well done, Andrew. And thank you again, Jonti.
No, it's been a pleasure, and congratulations both. It's a great achievement.
Yeah.
Thank you, Jonti, and thank you for filling in for these last several weeks. And we look forward to getting you back on again real soon. Yeah. Appreciate it.
Sounds good.
Thank you.
Professor Fred Watson, astronomer at large, and Professor Jonti Horner, Professor of Astrophysics at the University of Southern Queensland. And from me, Andrew Dunkley, thank you again, and we'll look forward to your company on the very next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast. Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at bytes.com.
This has been another quality podcast production from bytes.com.